Hey everyone, and welcome right back to The Explainer. I am super excited you're joining us today because we are tackling something absolutely essential for anyone playing around on the bleeding edge of tech. We're talking about Agentic AI. These incredibly cool autonomous systems that are literally designed to think, plan, and act all on their own. But if you've been paying any attention lately, you know they definitely do not always get it right. In fact, sometimes they fail in the most spectacular ways possible. So today, we're going to demystify exactly why that happens. We are pulling some brilliant insights straight from the Tech Horizon with Anand Vemula channel to break down the mechanics of these failures. We're turning that unpredictable software chaos into clear, actionable, no-nonsense understanding. All right, let's just jump right in.
So, let's talk about the elephant in the room, right? Why on earth do smart AI agents do such dumb things? I mean, it's a huge source of frustration and honestly, a bit of bewilderment for a lot of us. You build this incredibly advanced system. It's trained on oceans of data. It can write complex code. It can analyze massive documents. And then, seemingly out of nowhere, it just completely derails on a basic task. It gets stuck, it hallucinates, it crashes, and when we see these wild, inexplicable mistakes, our very first instinct is usually to blame the machine, almost like it has a mind of its own. We sit there thinking, what in the world were you trying to do? But to actually master these systems, we've got to get past that initial frustration and really look under the hood.
Okay, let's dive into this. There's a massive myth floating around out there that AI failures are just unpredictable magic, that they are these rogue machines acting out of some mysterious digital willpower. We need to throw that idea right out the window. Actually, scratch that. Let's completely destroy it. The reality is way more grounded. AI failures are simply software with predictable bugs. At the end of the day, these agentic systems are just built on code, architecture, and logic. When they break, they're exhibiting systematic, completely fixable flaws. They aren't plotting against us, they're just hitting a specific breakpoint in their design. Adopting this sort of forensic mindset, that is exactly what empowers us to stop being victims of bad AI and start being architects of truly reliable AI.
And this is exactly where our lead investigator for today comes in. Expert Meenakshi Kodati over on the Tech Horizon channel absolutely hit the nail on the head with this. She says, Agentic AI failures aren't random. They happen for clear, predictable reasons. That right there, that is our guiding principle for this entire explainer. Because if we apply that framework, we're no longer just guessing, we are actively diagnosing the problem. If these failures aren't random, it means we can categorize them. It means we can study them, figure out the specific triggers that cause an agent to just completely break down, and best of all, we can engineer those triggers right out of existence.
So what are we actually dealing with here? Meenakshi outlines the top failure modes in these systems, and they basically boil down to three main culprits: infinite loops, hallucinated planning, and unsafe tool use. This is our rule of three for today's forensic autopsy. You have to stop thinking of these as mysterious glitches and start seeing them as specific logic errors that an autonomous agent commits when it's left to its own devices. Each of these three culprits attacks the reliability of an AI system in a totally unique way. And if we want to build better software, we have to know exactly how they operate. Let's break down the evidence for each one.
All right, first up, infinite loops. This is when your AI agent gets stuck endlessly repeating the exact same sequence of actions or thoughts over and over without ever reaching a resolution. It's the perfect example of a system that has zero self-awareness about its own progress. Imagine a dog super enthusiastically chasing its own tail. It is burning a massive amount of energy, it's highly active, it probably feels like it's doing a great job, but it is going absolutely nowhere. In the real world of an agentic system, your AI might query an external database, hit a tiny syntax error, try the exact same query again, get the same error, and just loop that process thousands of times. It just burns through API calls and token limits like there's no tomorrow. It's a systemic trap, keeping the agent stuck until someone literally pulls the plug.
Which brings us to the second culprit, hallucinated planning. Now, this happens when an AI constructs a highly detailed but completely fictitious, completely illogical sequence of steps. And the really wild part here is that the agent isn't just making a tiny math error. It is confidently drafting an entire master plan that has absolutely zero connection to reality. Think of a super confident but totally lost tourist. They've got a map scribbled on a napkin, they are assertively pointing down a dark alleyway, and they are 100% positive that the Eiffel Tower is just around the corner in the middle of downtown Tokyo. The AI is doing the exact same thing within its context window. It strings together all these plausible-sounding steps that when you actually try to execute them in a real software environment make literally zero sense. But here is where things get genuinely scary. The third culprit is unsafe tool use. And this is the jump from my harmless internal logic error to an actual real-world risk. This happens when an agentic system improperly executes external actions, which can cause unintended real-world consequences or even massive security breaches. Look, agentic AI is so powerful precisely because we give it the keys to the kingdom. We give it access to email, to APIs, to live databases, to financial systems. But when a hallucinating or endlessly looping agent suddenly starts using those tools, no way, that is incredibly dangerous. It's basically like handing a loaded nail gun to that confident lost tourist we were just talking about. If the AI doesn't understand the strict boundaries of the tools it's calling, a predictable bug turns into an unpredictable disaster for your entire infrastructure.
Okay, take a breath. Thankfully, we don't have to just sit back and watch all this chaos unfold. We are shifting gears now from the forensic autopsy to the preventative medicine. Because according to Meenakshi Kadadi, making these systems reliable comes down to 3 incredibly actionable steps. Step 1, better design. We literally have to architect these agents with much clearer goals and rock-solid internal logic right from day one. Step 2, constraints. We absolutely must build strict digital fences. An agent should never have infinite attempts to run a broken query, and it for sure shouldn't have unrestricted access to every tool on the network. And step 3, monitoring. You need a system that watches the system, you know? You need an oversight mechanism that can spot that dog chasing its tail or that lost tourist and immediately intervene before any real damage is done.
So we've covered the absolute core concepts today, but there is a whole lot more under the hood if you want to master this stuff. If you want to keep this focused learning journey going and really figure out how to build bulletproof AI, you have to check out the source material. You can find the full deep dive over on the Tech Horizon with Anand Vemula's channel using the link we've got right here. I highly recommend heading over there to see how Anand and Meenakshi expand on all these critical failure modes, and more importantly, how to actually engineer your way out of them.
Which brings us to our final thought for today. We've seen the culprits and we've talked through the solutions. So I'm going to leave you with this to ponder. How are you going to implement strict constraints to tame the AI agents on your own tech horizon? Because honestly, information is only as good as the action it inspires. Take a hard look at your own projects, your own tech stack, or even just how you interact with AI every single day. Where are those infinite loops hiding? Where are the guardrails completely missing? Take these forensic insights, go build some safer software, and just keep learning. Thank you so much for hanging out with me on this explainer, and I will see you next time as we keep making sense of this wild technological world.